if you have your periodic table I gave you on the first day, look at carbon. See what carbon's is. I'll give you a second. Or you can look it up on the web, whatever you want to do. But when I notice carbon, it says it's 12.01. Well, how do you get 12.01? If the mass is protons and neutrons, then how do you get 12.01? Or, what about chlorine? Chlorine's 35.45. That doesn't make any sense either. Turns out that when you're talking about atomic mass, it's the average atomic mass. You have to think about all the different isotopes that are out there. And you learned about isotopes before in some other class, but all they are is different numbers of neutrons. And what you have to do is a weighted average, just like your grade. Your grade is not tests, quizzes, homework, everything counts the same. It's weighted. Some things have more importance than others. And this is no different than average atomic mass. So for us to do an average atomic mass, all we have to do, and this is the simplest thing in the world, all we have to do is take the isotope, the mass of it, times the percentage. And then take the second isotope times its percentage, and so on and so on and so on. If you have 15 isotopes, you got to do it 15 times. And you add up. You never divide. Never divide. Never divide. If I was going to do this one, I would do 14.003074 times 99.63%. Well, that's times 0.9963. And I would do 15.000108 times 0.0037, because that's tricky. And then I'd add them together. I wouldn't divide by 2. If you divided by 2, you're going to get something like 7. There's no way you average together 14 and 15 and get 7, right? So we don't ever want to divide. We're going to 14 point that and 15 point that times those two percentages. You guys should be able to tell 14 is much more important here at 99.63% than nitrogen 15. And the average atomic mass ends up being 14.01. And that's really easy to do. This is one for y'all to try. You guys take the percentages right here. Go ahead and multiply them through. Go ahead and hit pause now. Go work it out. Then you guys can find an answer. If you want to know if you're right or not, all you have to do is look at the periodic table, 28.09. That's what the periodic table says, and that's what your answer should be pretty close to. Now, I like to think of the next as a trip to a country called Malaysia. Malaysia is one of my favorite places to be. Malaysia is a city all about the mole. And what is the mole? Well, a mole is a concept that connects several different things about elements. You can do several different things. You can count elements, which is what we're going to be doing over here in counting how many particles there are, or you can weigh elements, and you can connect them just like the roads connect through this concept called a mole. Now, their capital city of Malaysia is Guacamole. There's Particle City and Mazikistan. If we are going to react chemicals with each other, we need to know how many particles or how many atoms or molecules are in that sample. So let's say you need 10 hydrogens and you want to mix it together with 5 oxygens. And when you do that, you're going to get 5 water molecules. Well, that's fine. But how do you get 10 hydrogens? Are you going to shrink down to a magic school bus and go looking for them? Are you going to sift through them and count them out with tweezers? No. You are going to weigh them out or measure them out in some way. So we need something that connects how many there are with how much something weighs. And that thing is the mole. A mole is simply this. We connect by the work of a guy named Avogadro. Avogadro was a famous scientist who looked at gases mainly, but he was able to come up with Avogadro's number, which he said that 1 mole of anything, didn't matter what 1 mole, what thing it was. It could be oxygen, hydrogen, whatever, is equal to 6.022 times 10 to the 23rd of something. Now, before you freak out, just remember, you already know stuff like this. What's a dozen? A dozen's 12. What's a gross? A gross is a dozen. That's 144. A few. What's a few of something? Well, a few is 3. So you already have words equated with numbers in your vocabulary. This is no different. It's just a really big number. 1 mole of something, of anything, was 6.022 times 10 to the 23rd. Now this is particles. Now particles can be many things. Particles can be atoms, or molecules, or a couple other things. That could be donuts. You could have a mole's worth of donuts. You could have a mole's worth of strips of bacon, whatever made you happy as a person. But also, very importantly, is 1 mole of anything. That same mole is equal to the mass in grams off the periodic table. So, if you have your periodic table, which you still should, go over there and look at, like, find calcium. 1 mole of calcium is equal to 40.08. My handwriting's atrocious. 40.08 grams. That's of calcium. And I know 1 mole of calcium is also 6.022 times 10 to the 23rd atoms of it. Okay, so he connected those two. Once you know that and understand the idea of what a mole is, you can do all kinds of stuff with it. So let's go back to our lovely map. And basically what you guys need to know is you guys just need to fill in a couple things on this map for me. If you are given moles and it wants grams or mass down here, then what's the speed limit on the periodic table way? The speed limit on the periodic table way is different for every element. So if it's calcium, it's 40.08. If it's lithium, it's 6.94. You need to look on the periodic table to find that number. 1 mole of something is equal to the number of grams off the periodic table. What's the speed limit on Avogadro Lane? That is always 6.022 times 10 to the 23rd. Let's imagine that you're making Oreo cookies again. Do you want to count out 10 million crispy chocolate wafers before you make a batch of cookies? No. It would be much easier if you had some way to connect particles of something, or how many, right here, with how much they weigh. And I'm pretty sure at the Nabisco factory, they actually have a chart somewhere that tells them crispy chocolate wafers weigh this much. And there, you can calculate, if you want this many crispy chocolate wafers, you need this many grams of it. And that way they can just load them into a big hopper and use them without having to count them out. That would be wasteful time. We will practice this some in class, so I just want you guys to get these notes in there so that you're ready to go. A couple facts about moles. I'll just let you guys look over it. There's always somebody with way more time than you who has figured this stuff out. I thought these were funny.